we're going to just work some graphing rational function problems from the homework assignment. This will be going on, this work will be going on the third 6 weeks, and this is the week before Thanksgiving, so I'm going to try to put together some stuff over this homework so that you can review over the break. Make sure you're ready to go when we come back from the break, because we'll be testing over this at some point after the break. So I'm just going to take some time and I'm going to work some problems from the review, from the homework page. So this is number 1. And I'm just going to go through the steps that I gave you on note card 42. Number 1 says, if possible, factor the numerator and the denominator. Nothing factors in the numerator, nothing factors in the denominator. Number 1 also says, if nothing cancels, to go on to step 3. So I'm going to move on to step 3. What happens here is, because nothing factors, nothing's going to cancel out, and we have no holes in our function. So move on to number 3, to find the X-Intercept. And to find the X-Intercept, I set the numerator equal to 0 and solve for x. So I have 2x plus 1 equals 0. And I subtract 1 from each side. Divided by 2. And I get that my X-intercept is -1/2. Number 4, to find the Y-intercept. Take my function and I plug in a 0 for x and solve for y. This gives me 0 plus 1 over 0 plus 1, which is 1 over 1, which is 1. So my y-intercept is 1. Step 5, find the vertical asymptote. To find the vertical asymptote, I set the bottom, the denominator, equal to 0 and solve for x. And I get that x equals -1 is my vertical asymptote. Step 6, find the horizontal asymptote. And I follow all the information on my note card. The part that gives me this on my note card, it looks confusing, but it's very easy. It says f of x is equal to a times x to the power of n plus ... over b times x to the power of d plus ... Well, if I look over here, I see that a is a number in front of x on top, so that's going to be 2. So a is 2. N is the power of x on top. N is 1. B is a number in front of x on bottom. That's 1. And D is the power of x on bottom, which is 1 as well. So D is 1. And on the note card, it gives you some instructions. It tells you that if n is equal to d, which it is, then my horizontal asymptote is going to be y equals a over b, which is y equals 2 over 1, which is 2. So y equals 2 is my horizontal asymptote. Okay? Once I've got all this, I have all of my information I need. I have my x-intercept as -1/2. I have my y-intercept as 1. I have my vertical asymptote as -1, and I have my horizontal asymptote as 2. There is no holes, and so now I'm going to give a very good attempt at trying to graph this without the use of a calculator. I'm going to erase some of this, give myself some room. And And yes, you do need to make yourself a little graph on your own paper. If you have graph paper, that would be a little bit better, but you could get it done either way, just like I'm doing here. Okay, so I'm going to just start by graphing my x-intercept, which is 1/2. That means it's going to cross the x-axis right between the 0 and the 1. Oops, that's -1/2. Sorry. Okay. Let's try this in a different color. -1/2 is where it's going to cross the x-axis, so I'm going to make that little mark right there. My y-intercept is at +1, so it's going to cross right there. So I know my function is going to go right in between those 2 points. My vertical asymptote is at x equals -1. So that's that vertical line. We're going to draw it as a dashed line that goes right through the -1 on the x-axis there. My horizontal asymptote is y equals 2. That's that horizontal line that goes right through y equals 2. And then that's all the information that I have. And so we should definitely be able to see that the right side of this graph is going to go right through the x at -1/2, right through the 1 at on the y-axis, and it's going to come up here and it's going to hug this horizontal asymptote when it goes out to +infinity for the x values, and it's also going to hug the vertical asymptote as it goes on to -infinity on the y-axis. And so I might be finished there, but at the same time, what I've been seeing with these types of functions, if it has this piece like this, it probably has another piece on the opposite side that goes like that. And after I do that, what I would do is I would get my calculator and I would want to check that to see if there's anything wrong with it or if I need to fix something. Now, if we take a quiz or a test, you're not going to have the calculator. The only reason why I'm telling you to use a calculator now is so that you can learn. Okay? You're going to use it as a learning tool to check yourself as you go along. But that's how you do number 1. And so let's just kind of move on and let's look at number 3. One over x minus 3. So I'm going to go through the steps. It says if possible factor top and bottom. Nothing factors top and bottom. And so I do know that there is a typo on your homework sheet where it says x equals 3 in the denominator. That's it probably was a plus because the equal sign is right by the plus. It's the same key on your keyboard. Let's just make it a minus 3. Doesn't really matter. We just need a good practice problem and it's going to serve its purpose. So nothing factors top or bottom. That means nothing's going to cancel. So there's no holes. Okay? So no holes. Just like the previous example. And I'm going to move on to step 3. Step 3, I need to find my x-intercept. Find the x-intercept. I set the top equal to 0 and solve for x. Well, there's no x in the top. It just says 1 equals 0. Is this a true statement? No, that's not true, so there's no x-intercept. That's how you would handle that situation. Okay? Next step, number 4, find the y-intercept. How we find the y-intercept is we make x 0 and solve for y, which gives me -1/3 is my y-intercept. My next step is the vertical asymptote. Set the denominator equal to 0 and solve for x. So so x equals 3. Next step is to find the horizontal asymptote.
Excuse me.
Yes.
Can I have a mirror Harrison to the phone, please?
Yes. To find the horizontal asymptote, we're still using that same information that I'm getting straight from your note card. And I've got to find A, D, N, and A, N, B, and D. So A is equal to, A is a number in front of X on top. There is no X on top. So let's just call that 0. Since there's no X up there, we'll call it 0. Okay? N is the power of X on top, and since there's no X, then there's not going to be a power on top as well. Okay? B is the number in front of X on bottom, which is 1. And D is the power of X on bottom, which is also 1. On your note card, we have a criteria where it says that N is less than D, and that's what we have right here. Because there was no X on top, N is going to be less than D, which means that our horizontal asymptote is going to be y equals 0. And that's how you would handle that situation, again, when there's no variable on top. Now we're ready to try to graph it. Okay, so I have no x-intercept, so nothing to graph there. I have a y-intercept at negative 1/3, which is going to be just below the 0. It's in between 0 and negative 1 on the y-axis. That's where it's going to cross the y-axis there. I have a vertical asymptote at x equals positive 3, so that's going to be that dashed line that goes through the 3 on the x-axis. And then my horizontal asymptote is y equals 0, which is that dashed line that basically makes up the x-axis here. Okay. Now, what we have going on, first of all, we need to talk about some things that we didn't talk about on the last example, but you should remember that my function never crosses the vertical asymptote, and it usually never crosses the horizontal asymptote. So in this case, what's going to happen is, since I only really have one point, and it's down here underneath the horizontal asymptote and to the left of the vertical asymptote, I'm going to say that this function is probably going to come out here and go to negative infinity, hugging that horizontal asymptote, and it's going to come this way and veer downward because it's never going to touch the vertical asymptote and go that way. And because I have this piece down here, I'm probably going to have this piece up here. And this is a very good attempt at graphing that, and after you do this, you would check your calculator and make any adjustments that you might need to make. Okay, let's look at number 10. Probably going to need some extra room here, so let me create some space. Okay, so the first step is to factor the top and bottom. If they do, The top one is pretty easy to factor. It's a GCF there. I'm going to take out a x. So when I pull out an x, I get x minus 4. And so there's my top. The bottom here requires a little Mustang factoring. And I'll go ahead and run through that. My signs are going to be different. The biggest one will be positive. Okay? So A is 1, B is 4, C is 30 negative, or well, doesn't matter if it's negative or positive. We'll take care of it in a second, but it's negative 32. A times C is 1 times 32 is 32. Then I look at the factors of 32. So I have 32 and 1, 16 and 2, 8 and 4, and I believe that's all. So if my signs are different, the biggest one's positive. That implies the smaller ones are negative. Which two add to positive 4? And it's the bottom two. So my next step is to divide by A, which is 1. And some people were making a mistake on the last test, and even the factoring quiz right here, they were forgetting to divide by A. Well, when you divide by A, if A is 1, it doesn't really affect anything. But when A is something other than 1, it changes it, because it changes this factor of 1 here. But my factoring becomes x plus 8 and x minus 4, which means that the x minus 4 factors cancel out. So I have a whole. And I need to find the ordered pair of that whole. And to find the ordered pair of the whole, what I want to do is I take the factor that canceled, set it equal to 0, and solve for x. And I get that x equals 4. This is the x value of my whole, because remember, if I have a whole, that's going to be an x, y value. So far I have x is 4, but what's y? And the way I find y is I go back to what's left. And I have x, y equals x over x plus 8 left. And I want to plug in 4 for x and solve for y. Which is 1/3. So my whole is at 4, 1/3. Okay. All right. So the next step, since I already have my whole here, is to find the x-intercept. To find the x-intercept, what I want to do is go back to what was left and set the top equal to 0 and all that I have left, and I'll just highlight what I'm talking about, what I have left. This is what I have left, so for right now, this is all I'm going to be using to answer these next questions. Okay, so the x-intercept, I've got x equals 0 is my x-intercept. Just set the top equal to 0 and solve for x, so I'm done there. My y-intercept, I want to plug in a 0 for x and solve for y. So I have y equals 0 over 0 plus 8, which gives me 0 over 8, which is 0. So my y-intercept is also 0. What does that tell me? That tells me my function is going to cross, it's going to go right through the origin at 0, 0. Okay. Step 5, I want to find my vertical asymptote. So I want to take my denominator, set it equal to 0, and solve for x. So x equals -8 is my vertical asymptote. And now I want to find my horizontal asymptote. And so what I want to do here is, when we're finding our horizontal asymptote, right now since something canceled, we're just going to go with what's right here. If something doesn't cancel, I notice there's a problem in your homework where something does not cancel, but after you factor it, and this is a side note here, so this is not part of what we're talking about as a problem, but I want to make sure you understand something. If you end up with something like this, and you're looking for n, which is the power of the x on top, that's not 1 here, because there's 2 x's. Okay, so make sure you realize that, because if I FOIL this out, I would get an x squared, and so you would need to know that that power, that n, the power of x on top, would be 2 there. So just be careful of things like that. Okay, so my horizontal asymptote, I have that A is 1 because it's the number in front of x on top. N, the power of x on top, is 1. B, the number in front of x on bottom, is 1. And D, the power of x on bottom, is 1 as well. So here I have n equals D. And so what I'm going to have then is a horizontal asymptote of y equals a over b, which is 1 over 1, which is 1. And so now what I want to do is I want to graph. So I'm going to make myself an xy plane like before and just go through everything and try to graph it. Alright, so my x and y-intercept are both 0s. That goes there. That's where it's going to cross the x and the y-axis. I have a vertical asymptote at x equals -8. So I will draw that vertical line, dotted vertical line right through the -8 on the x-axis. I have a horizontal asymptote at x equals 1, or I'm sorry, y equals 1. So it's going to go right through the y-axis at the 1, just like that. And this is, well, I do have a hole. Can't forget my hole. I have a hole at 4, 1/3. So that's over here somewhere, about like that right there. And so it's kind of the same what we've been doing here. It looks like this function, if I'm approaching positive infinity on the x values, it's going to hug that horizontal asymptote all the way out. It's going to come back through here at the origin, and it's going to go down, never touching the vertical asymptote, looking like that. And I'm also going to take that step and think that this other piece probably out here looks like this. And then my next step would be to look at my calculator and see if there's any changes I need to do, or if I'm good to go, and it looks like I'm probably good to go here. That's how you work these problems. You have to just stick close to that note card 42 where it talks about graphing the rational functions and follow each step. There's nothing really new there. We've learned everything as far as setting everything equal. Whatever you have to do, like to find the X-intercept, you just set the numerator equal to 0 and solve for X. You've been solving for X for a long time. First thing we'd have to do is factor the top and the bottom if they do. We've been factoring for a long time. We can do those things. Follow those instructions all the way through, and really the only new thing here is attempting to graph this without a calculator. And as we're seeing, I hope that we're finding it's not too bad. It's a sign.